Okay, so in this video, I'm going to be finding the antiderivative of x sine x dx. So I'm going to be using integration by parts for solving this. So integration by parts. And why am I using integration by parts? Because I can't really use the other methods I know. I can't use substitution. If you try, that won't really work out for you too well. I can't use the reverse power rule simply to solve this question, so I really can't do anything. Because if I had like just the x alone, I could use the reverse power rule, becomes x squared over 2. But here I just have all of this other stuff. I can't really do anything that I know of, so I can use the integration by parts formula, which is as follows. So if I want to find the antiderivative of u dv, this is going to be equal to u times v. Make sure you make your v's look different from your u's, minus the antiderivative of v du. Okay, so this is what we need to solve this question. Once we know this, and once we can identify our u, really this isn't too challenging to solve. So again, we can use our acronym that we have, LI8. Okay, so I'm not going to write out what these mean, because I did cover that in a previous video, but I'm just going to say that this is logs, this is inverse trig, this is algebraic stuff, this is trig, this is exponential stuff. So I'm going to say u equal to, in this case, the algebraic stuff, that's x. So du is going to be equal to dx. So then now I can set dv equal to the remaining stuff, that's just sine x dx. And then if I want to find the antiderivative of this to get v, this is going to be equal to, so let me write this here. What is the antiderivative of sine x dx? Well, this is just going to be equal to negative cosine x plus c. And we can write that here, so that's just negative cosine x. Now, this plus c is not necessary because it'll be canceled out later. We won't it won't make a huge difference, so we don't need to add that. Okay, so now we can use this formula here. Let me do this in blue. So this is the antiderivative of x d, so dv is sine x dx, so x times sine x dx, and that's literally this. And this is going to be equal to, because that's what we want to find, uv, which is x times negative cosine x minus the antiderivative of negative cosine x, and then du, which is dx. I can bring this negative out, making this plus cosine, the antiderivative of cosine x dx. And then we have this stuff here as well. So x times, or negative cosine x, negative cosine x times x. Okay, so what is the antiderivative of cosine x? So the antiderivative of cosine x is just going to be sine x. So this is just equal to plus sine x. And then we have this negative cosine x times x. And then remember to add that constant of integration. And this is your final answer. This is the antiderivative of x sine x. Okay, so now we can check our work by finding the derivative of this, and we should get this here, so let's do that. So the derivative of this, we can split it up, and so we get d by dx of negative cosine x times x plus d by dx of sine x. So the derivative of sine is just going to be cosine x, and then here we have negative cosine x times x. So we can use the product rule. You can obviously bring this negative outside. We don't need to worry about that. So this is just cosine x times x. So we can use the product rule. That's just going to be 1 times cosine x plus cosine x, the derivative of that is negative sine x, times just x. So we can simplify here. This is just cosine x, and this should be negative everything. So negative cosine x minus sine x times x. Okay, and then plus cosine x, and then this just becomes minus cosine x plus sine x times x plus cosine x. And now it's pretty obvious that this will cancel with this, making this all equal to sine x times x, which is exactly what we had over here. And the integration by parts formula worked beautifully. So I hope you found this video helpful. I will be doing more challenging questions in future videos.